Well, it would have been algebra 1. And the discriminant is nothing more than the value of b squared minus 4ac. That you should recognize, right? You don't recognize b squared minus 4ac? You've never heard of that in your life? How about in the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. So b squared minus 4ac should ring a bell. So the reason we talk about the discriminant is because just from calculating that, you should be able to tell me something about the type of roots that you're going to have without actually doing the entire quadratic formula. So here's your 3 scenarios. If the discriminant is 0, what can you tell me about the type of solutions? Are they going to be real or imaginary? Is when you try to take the square root of 0, is that going to be a real number or an imaginary number? It's 0. The square root of 0 is 0. That's a real number, right? So you're going to get real answers here. How many? Essentially, you're taking a number and you're adding 0 and then dividing it by 2a. And then on the second hand, you're taking a number and you're subtracting 0 and dividing it by 2a. What happens if you add 0 versus subtracting 0? What's different? Nothing is different, right? So you're actually going to get the same answer twice, yes? Which really means you only got one answer. So this would equal one real solution. And then in another case, let's pretend you get the square root of a negative number. I'm just putting negative number under my radical. If your discriminant is a negative number, are we going to get real or imaginary? Imaginary. And how many? 2. 2 imaginary solutions. And we sort of started talking about this yesterday, but they'll always be conjugates, because one's going to be a number plus the imaginary, and the other one's going to be the number minus the imaginary, and there's your conjugates right there. Both divided by 2a. They'll be conjugates. So write that. And you cannot have one imaginary solution. It's impossible. We started talking about that yesterday too. You always will have 2. And then the third case is obviously if that discriminant is a positive number, in which case you have real numbers, and again you'll have 2 of them, because you'll have a number plus the number and a number minus the number, and that'll kind of divert you in 2 different ways. So that'll be 2 real solutions. Have you guys ever realized, I can't remember if I pointed this out, does this part look familiar? That's the x-coordinate of your vertex. And so that is also there for a reason. And then if you know your vertex is at negative b over 2a, this always gives you your roots, which are always, if you add to one side, the same number that you subtract to get to the other side. That's what kind of keeps your parabola symmetrical, because you're adding that number and subtracting that number, so it's keeping everything symmetrical around your negative b over 2a number. Yes? Okay. So I pretty much just did the entire top section, but we'll just fill it in accordingly, a little more organized. So this wants us just to calculate the discriminant, and they're calling that capital D. So what's b squared in this case? What's b squared? Which is 9 minus 4 times an a of 1 and a c of negative 10. That's going to be 9 plus 40, so 49. So our roots, we don't really need to go and find them, but we do know that they're going to be 2, because that's a positive number, real roots. Okay, in case 2, what's b squared? 36 minus 4 times an a of 1 and a c of 7. That's going to be 36 minus 28, which is 8. So again, that's a positive number. We're going to have 2 real roots. But what's the difference between case 1 and case 2? Because they're kind of calling those 2 different cases, even though they're both positive numbers. And when I did my little quick synopsis up above, I just called all positive ones 2 real roots. See how? Right. One's a perfect square and one's not. So what is that going to do to the type of root that you have? In this case, you're doing negative 3 plus or minus the square root of 49 over 2. And in this one, you're doing 6 plus or minus the square root of 8 over 2. What's going to be the difference in these 2 roots versus these 2 roots? They're both going to be real. Which ones are going to be nicer? Chris? The top one. Because you're taking the square root of 49. And another synonym for nice numbers in math is what? Not necessarily whole. Nope. Let's do negative 3 plus the square root of 49 divided by 2. Oh, this one coincidentally happens to be a whole number, but it doesn't have to be. Sometimes you could get like, what if I did negative 3 plus the square root of 36 divided by 2? That's not a whole number, but it's still nice, right? Versus in this one, if I do 6 plus the square root of 8 divided by 2, that's what we would call not nice. So what's nice versus not nice in math? Rational and irrational, but terminating is part of what makes something rational, yeah. So these are rational because they're nice. And these are irrational because it's not a perfect square and you're taking something, a square root of something that's not a perfect square, so it's going to be a not nice number, which is irrational. Have you ever called your mother irrational? Have you ever thought that, Mom, you're being irrational? Yeah, that means she's being not nice or not logical. And this number is not logical because it's just all over the place. It's acting irrationally. Okay? All right, and then the other 2 cases we've talked about, so really quickly, b squared is 100 minus 4 times an a of 1 and a c of 25. That's 100 minus 100, which is 0. So we only have 1 real root when our discriminant is 0. And then in D, same thing, b squared 64 minus 4 times an a of 1 and a c of 20. 64 minus 80 is negative 16. So a negative discriminant means I'm going to get imaginary. So, how have we seen this come up on the regions? Here was one. Now, you could get this right, certainly without knowing anything about the discriminant, because you could just solve all 4 of these, right? Start to finish, you could do negative b plus or minus the square root. You do quadratic formula for all 4 of these, and just sort of wait until you get to one that has 1 minus I as a solution. But that's a lot of work. So to at least help eliminate the need for some of that, you could just calculate the discriminant for all 4 of these. And if we know our solution is 1 minus I, then we know our solution is imaginary. So what type of discriminant are we looking for? Negative, exactly. Does that make sense? So really quickly, if I just did just the discriminant test, b squared would be 4 minus 4ac. That's going to be 4 plus 8, correct? So that has a discriminant of 12, so that's out, because that's going to have real solutions, not imaginary solutions. If I check 2, b squared is 4 minus 4ac. That's going to be 4 minus 8, yes? Which is a negative discriminant, so that's still in the conversation. We can't get rid of that. In 3, b squared is 4 minus 4ac. That gives us 4 plus 8 again, which is 12, so we can take that out of our conversation. And then on the last one, b squared minus 4ac gives us a discriminant of negative 4. So it's between 2 and 4 at the very least. And then unfortunately there is really no way other than to go ahead and do the entire quadratic formula with both of these. The nice part though is we've already done the discriminant for each of them. So for 2, if I do negative b plus or minus the square root of the discriminant, I already know that that's negative 4. All over 2a is just all over 2. And so if I'm simplifying this quadratic formula, the square root of negative 4 is what? 2i. So negative 2 plus or minus 2i all over 2. And then I can reduce both of these because they're both divisible by 2. So negative 1 plus or minus I. Is that is one of those solutions that one? No, right? Because this has a positive 1. So I think by default it will be 4, but you should just check to make sure you didn't make a mistake. The opposite of b plus or minus the square root of the discriminant, which is negative 4, all over 2a, which is 2. That'll give you 2 plus or minus 2i over 2, which is 1 plus or minus I. So 1 minus I is within that. So that particular one, the discriminant helps quicken the process. It really isn't fully necessary though, right? You could avoid it just by doing the solutions for all of them. But there are some that are unavoidable, so hang with me here. In number 3, they say, consider this quadratic. Determine the number of x-intercepts. By the way, the number of x-intercepts, you guys should know, that's the number of solutions, right? That's kind of what we've been talking about. Determine the number of x-intercepts from the value of its discriminant. So if this was an open response, we would be looking for, do they know what the discriminant is? And so we're going to calculate that first. What's b squared? Minus 4ac. What's that going to be? 0. So how many x-intercepts should we have? Just 1. When the discriminant is 0, you have just 1. So where is it? How do you find the x-intercepts? What would your flashcard say? To find the x-intercept, you set y equal to 0. And solve. Now we could solve by the quadratic formula, or this is factorable. What does this factor into? Say it again, Lucas. Right. It's the same thing twice. So when you tee this up, you're going to get x equals 2 as a solution and x equals 2 as a solution. Well, guess what? Just to make the parallel, if you were doing the quadratic formula, you would have gotten 4 plus or minus the square root of 0 all over 2. So 4 plus 0 over 2 would have been 2, and 4 minus 0 over 2 would have been 2. You also get the same answer twice. Do you see the connection? Whether you do it by the quadratic formula, you get the same answer twice because of that 0. Or whether you factor, you get the same answer twice because of that 0. And so the y-intercept is just 2, or x-intercept rather. And does this parabola open up or down? Up. And what's the y-intercept? Right there, right? Your c value. So if I just kind of guesstimate where that is, that'll give me somewhat of an accurate curve. And just so you know, this is what it's called to be tangent to a line. This parabola is tangent to this line. Has anyone ever heard of that phrase before? You know what a tangent is from geometry, right? A tangent to a circle is a line that hits it just one time. You can be tangent to any curved thing. So this is tangent to the parabola because it's hitting that curve in only one spot. Okay? So exercise 4. Again, you could answer this if you solved 4 different quadratic formulas until you found 2 unequal rational x-intercepts. Or you can just take a shortcut and do it based on the discriminant. Any questions on that? Okay, we're going to skip it because these are the ones that I get most worried about, that you 100% need to know what the discriminant is, otherwise you don't have a chance. This is the Common Core and how they get not tricky, but they want to know whether or not you understand the discriminant, and unfortunately it can be avoided here. And it can sort of be avoided there for the most part, unless they actually use the word discriminant, and it can definitely be avoided there. So they have to find a way to test it so that they can ensure that you actually understand the concept. So I don't think it's that they're trying to be tricky. I think that they're trying to prevent you from being able to circumvent the whole thing. So they'll give you a parabola, and they'll be missing either A, B, or C. This one's missing A, this one's missing B, this one's missing C. And they'll say, what values of A would cause this to not cross the x-axis? If it's not going to cross the x-axis, you need the discriminant to be what? Greater than 0, less than 0, or equal to 0. Right. You need the discriminant to be negative if it's not going to cross the x-axis. So if you need the discriminant to be negative, then you need it to be less than 0. And then you guys can just plug in what you know. B squared would be what? 16 minus 4 times A times C is 2. And just solve this. So 16 minus 8A has to be less than 0. How do you want to solve this next? Okay, subtract 16. Some people like to keep their A positive, so that's why I asked. But Bella's good with this. Then what are you going to do, Bella? And then what's your answer? What? Give me the sentence. No, A is greater than positive 2. Do you know why? Correct. So that's why people sometimes avoid keeping a negative 8A. They might have chosen to add an 8A over. And in that case, those people would have gotten 2 is less than A, which is the same thing. 2 being smaller than A is the same as A being bigger than 2. Okie doke. Really can't avoid the discriminant in this case. For what values of B will this intersect the x-axis exactly once? If you want it to intersect the x-axis exactly once, then the discriminant needs to be what? Equal to 0 exactly, correct. So we have B squared minus 4 times an A of 1 and a C of 25. That's B squared minus 100. Add 100 to both sides. B squared equals 100. So Mike, what values of B? You did it again. What did you learn from your homework quiz today? Plus or minus. Shoot. I gotta get that. Oops. B could be positive 10 or B could be... Now, once you get these answers, certainly I would recommend you use your calculator to check. So I could type in x squared plus 10x plus 25 and just confirm that it hits only once. On number 5, I could make my A slightly greater than 2, even if I make it 2.1. It'll make it not cross the x-axis at all. Wow, just that little change of making it slightly greater than 2 made it not touch it, not even close. I thought it would only be off by a little. Versus if I make it exactly 2, what? I have something wrong here. I knew that was not right. Oh boy, I got a whole bunch more in there than I wanted. 2.1 x squared plus 4x plus 2. That's more what I was expecting. That actually looks like it is hitting, but if I zoom in over here and get real close, I'll see that it's actually not touching. You may even want to zoom in again. There. Now I can see that it's not touching. But I only made A off by a slight amount, so it was only missing the x-axis by a slight amount. Okay? We get the idea? Any questions? You have your spiral, and here comes your discriminant homework. You guys did miss your spiral on the front table because I know there was a lot and people missed a lot. Grab that on your way out. Olivia, what are we doing in Disney? Just Disney, or are we going to Universal? Just Disney. Do you go every year?